say as 8 hours for postgraduate. So start session with on camera, and then lepas tu off, then as long as we verify kehadiran pelajar with their image of the camera on. That's all. Okay, and then synchronize camera to examination session.
Oh, for your final exam, you need to open for the online, synchronized online exam with online invigilation. You need to open the camera through exam session, huh? No invigilator, no protocoling. Okay, okay. Later we will inform you about the final exam. But okay, I continue. That is the things that I mentioned. You need to know also about others. And this lastly, step number 6, implement counter implementation. You need to draw back the circuit, your flip-flop, and the overall counter that you have. Okay, before you're going to learn on all of these steps, before that, you need to know on the excitation table. Last time you ada table yang I asked you to remember this, the summarization table that you need to remember for JK flip-flop. Mana? JK flip-flop, what is the table? D flip-flop, T flip-flop. Similar also in this step, but there is new table that you need to remember. Before you can remember, I asked you last time to know how you get that kind of table, the derivations of the table. So first of all, we're going to look the derivations on your JK flip-flop. Okay, for your JK flip-flop here, if you still remember, last time you have this kind of table. Mana I punya pen ni? This kind of table, JK 00011011. What is your output? Your Q. This one is what? Last time we call it as the output of Q, and we are referring to your previous Q, right? So we have here no change. This one is reset. This one is set. And lastly, this is your toggle, isn't it? So you need to remember this first. But now you need to have the next step table. Means that you need to have Q next. Next Q. So you're going to have this. You assume this is, ya Allah, kenapa saya punya pen ni? You need to assume this should be your previous, and this will be your next. And sometimes we can call it as this is a present, this is the next. So in this situation, you can see here, ya Allah. You have this kind of things. This will be your no change. This will be your reset. This will be your set, and this will be your toggle. And how about the previous Q? Previous Q, sometimes it can be 0, sometimes it can be 1. Sometimes it can be 0, sometimes it can be 1, sometimes it can be 0, 1, 0, 1, isn't it? So this is the previous Q. Last time you refer to your previous Q to do a changes to your output Q, isn't it? This is your previous Q last time, okay? And then you're going to get the Q referring to those. If there is no change, it's going to be 0, 1. If it is reset, it's going to have 0, 0. If it is 1 or set, it's going to be 1, 1. And lastly, your toggle is going to have 1, 0. So this is what you learned last time. Now, the name it will be going to change to be next state. Here is our next state table, and our previous now we call as present. And the symbol will be QN plus 1. This is next state, this is present state. You're going to get like this. Okay? Buang yang I lukis tak cantik. So we're going to have like this. No change. Previous is 0. Next will be 0 because no change. Reset, everything will be 0. And set, it will be 1. And toggle will be like this. This is the things that you dah belajar. Bukan I baru nak ajar, you dah belajar in your module 7. Module 7. Kalau you tak faham lagi, you need to repeat again. Why you get this so? Okay. Now, the new things is you want to create this next step table to come up with your excitation table. This is the things that you're going to use in your step 4. So, by having this thing, we can conclude with your several things. We're going to look into the Q. Saya lukis tapi dia tak muncul. QN plus 1. What is QN? Present state. I malas nak tulis, saya punya pen tak detect. QN plus 1 is what? Next state. Okay, I have this. Okay, I have this one. I have this one. What I'm going to come up with. This will be my if. This is my JK flip-flop. I'm going to find out what is the value of my J and K. Last time you were given with the value of J and K, right? That's why you can directly get the timing diagram. We're going to get the diagram, state diagram, state table, and etc. But now you don't know. The first step just now I mentioned, you don't know the connection or value of J and K. Okay, that is the first thing that you need to know. Now here, when we have these two, we can have the possibilities of 0, 0, 0, 1, 1, 0, 1, 1. Okay, there is a possibilities like this. When you have 0 and then suddenly your output will be 0 back. When you have the present state of 0, you can have the next state of 1. You can have the present state is 1, you can go to the 0 and etc. Okay. After that, how you going to define your value for your J and K about your connection? About your connection of J and K. Is it connected to high? Is it connected to low? Susahnya I nak draw macam ni. So you don't know. You don't know yet. But you already know about the Q. Last time you don't know about the Q because you need to find out what is the next Q last time, right? Now you know what is the next Q. The next Q is now given here. So you need to come out with the value of this input. Okay. So here, we have this table. We check at the condition of 0, 0. This is one of 0, 0 situation. This is another situation of 0, 0. You check all, there is no more. You're going to have only 2 here. Because there is 2 conditions to be 0 from present and 0 to next state, you're going to look into the value of J and K. You're going to look into the value of J and K. First, you're going to have 0, 0, this one. Next, you're going to have 0, 1. So you have these 2 possibilities to get 0 to be 0. Because of this, you can summarize that J is always 0. And about the K, it can be 0, it can be 1. So we assume it should be X. X, last time we know it can be 0, it can be 1. That's why you put X there. Done with your 0, 0 things. This is just for derivation, because you can just directly remember the excitation table, but I teach you now how basically you get that derivations of your excitation table. So for the scenario of 0, 1 here, we have the scenario of 0 from present state go to the next state of 1. Present state is 0. And next state is 1. So we have these 2 conditions. What we'll have? We have these possibilities and we have these another possibilities. Our J is 0. Our K, silap. Our J is 1. Our K is 0. Our J is 1. Our K is 1. See this and this condition can make the present 0 to be 1, present 0 to the next set is 1. So because of this, we assume J is always 1 and our K now here is X. This is what our condition will be. So next one, we have what scenario? We have present state as 1 and next state is 0. Present state as 1. Next state is 0. Okay, these 2 conditions. Now we have the conditions of J equal to 0, K equal to 1. And another one is J equal to 1, K equal to 1. So I can conclude that my J is X because it has 2. Sometimes it can be 0, sometimes it can be 1. And my K is always 1. Finish my third one. And coming out from 1, 1 here. For 1, 1, 1 from the next present state to the next state is 1. This is the condition. And another one is this one. The condition is this. So we have J is 0, K is 0, J is 1, K is 0. So we assume K is always 0 and J is X. Okay, it is very ugly there. So you can come up with this excitation table for JK. You can always just remember this, but in terms of the derivation, just now I already mentioned, how come you can get this table? So you're not going to question out, kenapa I nak kena ingat macam ni, tapi ini apa? What is this? What is this? If you don't know it, then you didn't understand how come you can answer a question, right? So any question in terms of the excitation table for JK flip-flop?
Get used to this online.
Okay, ada soalan tak?
Tak.
Tak ada soalan, doktor. Okay, if no question, we will move to your next. But before that, from here, you can see mana I punya pen ni. Oh. I have two situation of my Q. My Q can be 0, my Q can be 1. Because this is one bit only. You can see this is one bit only. We have present for Q, we have present for Q plus N. If you have two bit, you're going to have JK, Q1 and Q0N. And the one is Q1N plus 1, Q0N plus 1. Then you're going to have 0, 0, 0, 0, 1. Apa? 1, 0, 1, 1. So what is the next state after that? From here, you can see you just have 0 to 0, 0, 1 to 0, and etc. You can see here, 0 to 0, 0 to 1, 1 to 0, 1 to 1. This is your next state, this is your present. But now, this is your present state, this is your next state. Okay, later on you're going to see that. But from here, when you have 1, you have 0. Balik. Okay, you will go over here from present to next. 0 to 0. And then you can have 0 to 1. And after that, you have 1 to 0. And then 1 to 1. Okay, so before I refer to the excitation table, I have this table things. 0, 1. For the first thing here, I'm going to go to 0 to 0 when I have the input of, alhamdulillah, 0, 0. Okay, I biar kat sini 1. And then for this one, I have 1 to 1. For 1 to 1, the condition is 0, 0 also for the input. After that, I have this third situation. 0 to 0, I have the conditions of input 0, 1. Done here. Next, I have 1 to 0. 1 to 0. What is the condition? It is 0, 1. And I have here 0 to 1. 0 go to 1. it will be the input of 1, 0. And next we have 1 to 1. 1 is goes to 1, similar at here. The next condition is 1, 0. After that, we have here 0, 1. 0 is go to 1. The condition is 1, 1. And lastly, 1, 0. 1 go to 0 and it will be 1, 1 here. So we can conclude that it always 0 for J and K can be X. For this part, J can be 1, X will be X. J is 1, K is X. And this one, we will have J is X, K is 0. And lastly is X and 1. So you can conclude it to be this kind of diagram. Okay. So any question? Because next time you were given with the state diagram, you need to come up. You were given with stack diagram. You need to come up with the logic diagram. You need to come up with the present and next state diagram. The transition table also. Before we going to go for the sekarang ni pukul berapa? Sorry 3. I nak you buat sangat sekejap. In terms of the D flip-flop, I want you to draw D flip-flop. You have 0, 1. You're going to have the conditions of present state. Yeah. Present state is going to be 0, 1 and also 0, 1 here. So that's why you're going to have 4 tables. 0, 0, 1, 0 and 1, 1. So what is your next state? Fill in the value here and then come up with your excitation table. Actually, your excitation table is already given. But how you get this? This is the things that you need to derive. Similar also for your T flip-flop here. The T flip-flop, you need to come up with the similar table and you need to come up with the excitation table just now here. And I'm going to explain later on. So we're going to go to the Jamboard. I nak you habis dalam 3:15 only because it is only simple table. After that we continue. Sekejap, I buka Jamboard. Kenapa Jamboard I slow ni? Okay, going to do with your lab group as last time. The question is, that is your Jamboard. Actually, just now I already shared to you what you need to do, but you need to construct the excitation table on the derivation before you can get the excitation table. And odd group will do P, even will do D flip-flop. Okay, do it now in your Jamboard. And 3:15. Casual. 3:15, I'm going to discuss about that. Okay, dah habis ke belum? Okay, group number 1 done. Tapi you put also your excitation table, so easier for me to explain. What do you want? Abang sip. Dah habis sapu dia buat ber. Baring tidur.
Tidur. Let me. Let me, Mom.
Your summarization for the excitation table yang dekat muka surat yang tadi I tunjuk tu. Group number tu tak ada langsung lagi. Alhamdulillah.
Apa? Hello? What?
Nanti kat rumah.
Wow. Technical.
Okay. 1 more minute. Group number 2. Hurry up. Number 4, 6.
Jelai.
Hey, Allah Akbar. Baring tidur awak demam kan? Okay, I'm going to share my screen now because only some of you still not yet finished. Okay, let's check one by one. We have group number 1 and doing a T flip-flop. Or T flip-flop over here. If you still remember your table last time for your T flip-flop, you're going to have T 0, 0, 1, 1. If your previous Q is 0, then you're going to have already 0, you're going to have 0 also, which is no change. If you have 0 to 1, you have changes, you're going to be if your previous Q is similar to your next Q, is going to be no change. So your T will be 0. And then if you have toggles, mean your T is 1, isn't it? For your FF, if you still remember. Now you can see here when you have Q is 0 for your present state, you go to the next state is 0 also, you're going to have 0 for T. If you have present is 1, you go to the 1 also, which is no change, your T will be also 0. So T will be no change if is the 0. And if T is 1, it is toggle. If it is 1, it's going to be toggle. You can see here from your present to next, from your present to next. So from this table, you can summarize to get your excitation table, which is your next, this is your next state. Your next state, if it is similar to your present state, is going to be 0 for your T. And if it is a toggle or Q bar, it's going to be 1. And your friend are doing also the situations for your diagram. You can see if it is 0, let's go back to 0, it's going to have 0 for T. If it is move or toggle, you're going to get 1. If it move and toggle, it's get 1. And if it's written back to the similar state, it's going to be 0. That's everything is correct. Group number 2. D flip-flop here. If you still remember that if you have D equal to 0, then your Q, next Q also will be 0. If you're having the next Q is 1, your D will be also 1. So you can see here, 0, everything will be similar for your next state. 1, everything is similar. That's why after this, for your step number 4, it's very easy for D flip-flop. You just copy your next state. You copy every single thing at your next state, you're going to get the value of your D. So the excitation table you can define is to be, it's supposedly easier, which is D. If it is a 0 and 1, your Q n plus 1 on. So this is the excitation table if referring to your module here. This is the thing that you need to remember. And When we have 0, we go to the 0 again. We're going to have 0. And when we go for 0 to 1, we have 1 there. 1 to 0. 1 to 0 is going to have 0, yes. And another one is 1, correct. So this is the citation that you need to remember. Next, group number 3 is flip-flop T. You do toggle things here and no change at this part. It is correct, and this is your toggle things, and this is following the previous QN. So everything is okay. Next, for group number 4, tak siap lagi. Group number 5. Okay, for group number 5, this is T flip-flop. You have the toggle things over here, and this one is similar to QNs. Then you can conclude like this, similar. For group number 6, D flip-flop, whatever similar to your next state, you're going to copy back to your D. That is correct. And last group, I guess, for group number 7, doing T flip-flop, this is toggle, this is Sam, so correct. So that is in terms of your derivation before you can come up with this. But you can just directly remember this excitation table. And where you're going to apply, after this, we're going to look into the example. Okay, now we have designed 2-bit synchronized counter from other section, because they already finished these things. Last time they asked me, Doctor, last time if in the question it's going to state whether it is a counting up or counting down. Yes, but why in this thing it didn't give any hint whether it is counting up or counting down. Okay, when you play hide and seek with your sisters, younger sisters, minor pen I, brothers, okay, you ask them, okay, start count. I tak nak tulis lah macam ni. Start count. And then what they going to count? They're going to count like maybe 5, 10, 15, or maybe 1, 2, 3, 4, 5, and etc. Did they count reversely? No, right? Because you know by default, okay, please count. It's going to increase. It's going to increase, and it's always counting up. Jarang sekali, macam dalam cerita Ferrari, jarang, you're going to ask, okay, can you help me count this? Can you help me count that? Jarang is going to be happen to count kira ke belakang or backward or down. So if you were not given with anything design a 2-bit down ke, a 2-bit up ke, it mentions that it's going to be count up. There will be a question informing about counting down. Okay, 2-bit down. 2-bit down means it's going to counting down. Why you have this? Because when you want someone to count reversely or down, you will mention. But when you ask them, okay, can you count? It mentions that it's going to be counting up. Okay, so that is the thing. There is a student ask me, kenapa tak ada tulis? Kenapa ada tulis for down? Kenapa up tak ada tulis? Okay. So I hope that for final exam might be it's going to be help if they mentions, but if they didn't mention, you need to know if they didn't mention, it's going to be counting out. Tengah pula I punya pen ni. Okay, now you have here 2 bits. 2 bits means you're going to have 2 flip-flops. And it is a JK flip-flop. J0, K0, FF0. You have another flip-flop, FF1, J1, K1. This will be your Q1. This will be Q0, isn't it? Last time, for the previous one, you have only 1 bit. Now we have 2 bit here. There is no input and output elements yet because you don't know the connection. You need to find out after this. Okay? Okay, just love it. Now we have the second step. Draw the state diagram. It is synchronized counter. It's going to be count up. So I'm going to have 2 bits. It supposedly have 0, 0, 1 bit, 2 bits. 0, 1, 1, 0, 1, 1. So I'm going to count up. This is a this is a state diagram that I need to draw. And I have here like maybe 2 marks. This one is 3 marks maybe. Step number 3, what you need to do, you need to draw the next state table. How the next state table look like? You're going to have the present state and also your next state. It will be 2 bits now. You have the Q0N, Q1N, present. Okay? You're going to have 0, 0, 0, 1, 1, 0, 1, 1. This is the things that you need to always flow with the flow 0, 1, 2, 3, 4, 5, 7 until 15 or until whatever numbers depending on how many bits you have. Okay, next for your next state here, when you are here, when you are at the 0, 0, what is your next state following the arrow until here? We got here the next state is our Q1N plus 1. Q0N plus 1. This is just a symbol to represent next state. This is just a symbol for present. For the present state. So from 0, 0, it's going to go to 0, 1. Next, when you are here, you're going to go to 1, 0. This one is easy because you know the flow already. Later on, if you just tulis without looking at the state diagram macam yang you pernah buat sebelum exercise this, you punya jawapan akan salah. So you need to follow basically at the timing, the state diagram, okay? Last time you follow your timing diagram, the table, state table, but now you need to refer to the state table. Okay, next, when you are in this 1, 0, where you're going to go? You're going to go to 1, 1. And another one is when you have 1, 1, you're going to go 0, 0. Okay, done already. Nanti kalau you dah kahwin, you akan rasa macam ni lah. Ma. Ada tak habis mama dia. Okay, nanti dah makin besar dia akan kurang panggil nama you. Then that time you akan rasa rindu. That is what your mom and your dad feeling now. So you start lah panggil mak dengan ayah you balik. Mama. Mungkin dia orang rasa, kenapa tiba-tiba anak aku ni? Tapi that is the things that you pun akan rasa bila you dah makin tua, anak-anak you akan kurang panggil you. Jadi waktu dia panggil mama, you sabar je lah. So over here, we have step number 3. We have the next step table. This is the things that you need to draw, and just now we already look into the answer. Okay, after we have this, we're going to have the new tables that just now you never learned before. Just now we know it is a transition table. You're going to copy this all back and you will add extra, which is on the JK transition. The JK value over here, that's the things that you need to find out. Sama macam tadi, this is the things that you need to find out, the value, okay? So now you have, here, first thing, okay, kita tengok satu-satu. You have the flip-flop 1, FF0, G0, K0, Q0. So that's why we will only refer to this 0. Present state and next step. Let we do the K0 first. Now Q, we do both because this is one flip-flop. Okay, now we have present is 0. It's moved to next step is 1. Referring your excitation table here from 0 to 1, what is the value? You have 1x. Next, you have the still flip-flop 0. I refer to flip-flop 0 first. Next, I have here from 1 to 0. Where is it? I have this value, x1. After that, at this part, I have 0 to 1, 1x. And then 1 to 0 again. 1 to 0, yes, it's going to be x1. So finish for my flip-flop 0 there. And then you're going to look into your flip-flop number 2. FF1. FF1, J1, K1, Q1. So you're going to look into your present Q1 and your next state Q1. From 0 to 0, what is the value? You're going to have 0x. And then from 0 to 1, you're going to have 1x. And then 1 to 1, you're going to have x0. And lastly, 1 to 0, you have x1. So kalau I tersalah refer this one, you inform me. So this is how you're going to fill in all this value. So you akan dapat itu jawapan I. This is the answer. So this is step number 4. After this, you're going to do the K-map things. How you're going to do? Okay, by referring for the similar transition table, we bring it here. We just want to see this present state and the JK transition. Do the K-map. How? So you're going to do and assume last time you have A, B input and then you have the output 0, 0, 0, 1, 1, 0, 1, 1. And then maybe your output is this. You're going to have x1, x1. So how are you going to draw your K-maps? You're going to have A, be 0, 0, 0, 1, 0, 1, and then you're going to put everything here, isn't it? So similar to this situation, but now we have in terms of Q1, Q2, Q1, Q0. So let me do the first thing. I will pick at last K0. This will be my Q1, Q0. I can have vice versa. Let me do it first like this. Later on, I give you another example. Q0, 0, 0, it will be X. 0, 1, it will be 1. And then X and then 1. So you just group it. Okay, in terms of this grouping here. Bareng tidur. Okay. I rasa esok pagi bilik I akan penuh dengan semut. Sleep. Tutup mata. Okay, now you can see here. When you have all this means that everything is true, then your K will be 1. Okay, related to X here. Still, there is some of the student asking me about X. What is happened to the X? Maybe you have this kind of situation. Okay, if it is like this, can I draw like this? No, it is wrong, especially for this one. Okay, what is the purpose of your K-maps? To find the simplification. How you going to get the simplification? By grouping your digit 1, not grouping your X. But what is the purpose of X? It can be 0, it can be 1. Yes, I know that. But what is the purpose? X is to help digit 1 to get bigger group. The bigger your group you have, the simplification that the more simple equation that you will get. That's why we're going to go much bigger. But the purpose of X is to help only, not to you to consider the grouping. Not for you like sit over here, oh, there is another X after I already group here. How about this X? Which I'm going to group? Am I going to group like this? Am I going to group like this? No. If you already have this one here, then there is no other one that you're going to have. So you just ignore it and assume it to be 0. So for this part, K-maps, the reason of K-map is to find the minimized version, simplified versions of your equation, right? A Boolean equation. How you're going to get the simplification? By grouping the ones, the digit ones. So you see here, you have digit 1 at this side. And you have x's. The function of x is to help. So can this x help me to get bigger group rather than I group myself? Yes, this x can help me to get bigger group like this. I can see there is another x. Can I group like this? No, I can't. So that's why I can group like this only. So what happened to this? I just ignore it because it doesn't help anything. So I assume it to be 0. So that is the purpose of x. If you still don't know about that. So here, you have the Q1, Q0 here, and it doesn't matter if you change this place. But your answer here should be similar in terms of mapping. Okay, I did the Q0, Q1. Q0, Q1. 0, 0, 1, 1. Okay, like this you can see, I changed the place. If 0, 0. You can see here, 0, 0. I have my J. J0 is 1. Yeah, and that is correct. How about if my Q is 0, then it will be here now. My Q is 0, my Q1 is 1. It is at this side. It will be 1 here. So you can see it's slightly different as long as you know what is the value of Q, what is the value of 1. Okay, now over here, my Q is 1, my Q1 is 0. So here will be my X. And another one is also X. Slightly different, but in terms of when you group, you're going to get similar answer. It doesn't matter also if you have much bigger, okay, in terms of this kind of K-map, you can also have like this for your J0, Q0, Q1, Q2. Or maybe you're going to do in terms of like this, Q2, Q1, and then Q0. It doesn't matter in terms of representations of this, but how you're going to fill in the value depending on your K-maps, your table here. You put basically in terms of the correct place and you group it. Then you will going to get similar output. Okay, go back to the specific pages. Where is it? Where is it? Okay, now we are here. So you can just map this J0 to this one, and then you group this one, you're going to put here in terms of your K-map. And then you have another one for J and K. So in terms of the value, you can see this value is fixed. Then you're going to pick the value Q0. Q0 is 1 is going to be Q0. If you are at here, you're going to have Q bar because it is 0. Okay, now you can see here for this part, you have the Q1 change in terms of the value. So that's why you're going to ignore. After you have done this, okay, let's say we have here, this is step number 5. We done already with K-map team, with grouping with the value of the equation. So let's me draw my JK flip-flop. FF1, J0, K0, Q0, J1, K1, Q1. Okay, I'm going to do the connection. My J0, K0 is connected to 1. After that, I have here J1 is connected to my Q0. K1 is connected to my Q0 also. So this is my 2-bit synchronized counter. So I'm done with this. Okay, any question for this part? If there is no question, you have plenty of time. I'm going to move first to the timing diagram here. Because it's small at this part. Oh, tak ada. Okay, but it's okay. I hope that you can see this one. Or might be, can I make it bigger? Okay, now you know that synchronized counter, you're going to use similar clock. And we're going to do at the positive clock just now. When we have this, our Q, Q0, J1, K1, high, J0, K0. Okay, this is your Q1. Okay, now we look one by one. As always, look at your flip-flop 0 first, as always. So here, this is your normal one flip-flop only. Don't consider and make, alamak, ini banyaknya flip-flop, macam mana nak settle ni? So you look one by one, slowly, step by step. Of course, you're going to finish it. Okay, so first at this one, you can see you have all the positive clock here. And assume it's going to start at the 0 and lower. When you have the GK flip-flop 0, 0, no change, 0, 1, reset, 1, 0, set, 1, 1, toggle. You remember this, right? When you have meet the positive clock, then you're going to refer to your JK value, isn't it? So what is your JK value for the Q0 here? It is always 1 and it's going to be always toggle. So you're going to toggle when you meet positive clock. You're going to toggle again. Toggle. Toggle. Then you're done already. At this part you're done. And ignore this. But now you can see your next flip-flop FF1, the value of J1 and K1 is depending on the value of this Q0. Okay, so you are referring this similar clock. You're going to trigger at the positive clock there. At every positive clock, you're going to trigger looking at the value of your JK. So start from 0. Now I have positive. What is the value of my JK? My JK now is Q0. Now it is 0. Because it's not yet coming out, it's just triggered to get the positive clock here. It assumed to be 0. If Q0 is 0, your J will be 0, K will be 0. What is happened? No change. Okay? No change. You continue until you meet another next clock. Now your Q0 is 1. At this stage, Q0 is 1. Then what you're going to do? You're going to do, if you remember, you're going to have like 1 and then drop. So there is a few milliseconds in between. That's why you pick the Q0. You can have, at this specific line, you can have 0 and 1, right? Together, because at this line. But before it's up, your positive clock already triggered. That's why you're going to assume your value is 0. Here will be 1. Because it's 1, you're going to do what? Toggle. You're going to toggle until you meet another positive clock here. Stop at this positive clock. What will happen? You're going to look into the value of your JK. Your JK is depending on your Q0 there. Your Q0 is 0. What happened? No change. Direct to next positive clock. Now it is Q equal to 1. You're going to do toggle. So this is the diagram that you will come up for the counter. That's why after that you can see This is 0, 0, and then you have 0, 1, and you have here 1, 0, 1, 1, and then 0, 0. So this is your sequence of your counter. Okay, any question? In the Telegram, there is information about your final. If you eligible to sit for a retest 2, you should see this message in virtual exam hall. If there is mistake, please inform your lecturer. Okay, there is student that asked me because she can't to see the e-test because she copy and discuss with others. That is the thing. Okay. Now, we have only 6 minutes more. Okay. That's why after this we're going to go to like design 3B. We have all of this, but you need to know the very beginning step by step first. 6 step here. You do it one by one. You're going to finish it with the answer. So just going slow until you finally reach the step number 6. Please make sure you try it first. Tomorrow is holiday. That's why I need to continue and didn't take any leave today. We will continue. I hope that I can try to manage to record, and maybe we will discuss back in our class later on related to your design 3B. And then after that you have what else to be done. And the most important to make sure that you really understand is at this part. Maybe you can try directly first to do this exercise. If you can do it, means that you really understand of all the 6 steps there. But if you can't to do, means that you need to directly go back to the basic, slowly do the step by step. Okay? Any question? Any other question? Okay, if there is no more question, we're going to end our class today. If you still didn't scan your QR code, please stay first. I'm not going to share directly. If you already done, you can dismiss. Thank you for your participation, and